Hello, algebra students. Mr. Lawrence here, and we're going to have a little hiccup in our lesson. Our homework tonight is going to be very much the same what we did the night before, but we're going to actually get some estimations of these irrational numbers I've been talking about. Now, remember, the rational numbers, by the way, their symbol is a Q. Rational numbers, if you remember, that includes all fractions, okay, and decimals that do one of two things. Decimals that they either have to end or terminate, and they have to repeat, or they don't have to repeat, but they don't end, they have to repeat. So for example, like 2.51, 251 hundredths, that ends, that terminates. Repeating would be like 6.7 with a bar over the 7. Okay, and then there's these things called the irrational numbers, and actually there are way more irrationals than there are rational numbers. You don't think so because your experience has been with rational numbers, even though you weren't calling it that. These are the decimals that never end nor repeat. They don't end, they don't repeat. Okay? So what we're going to do is we're going to learn how to estimate those square roots, those irrational numbers, using a rational number. We'll use a decimal to about the nearest tenth. Okay? Sometimes you can get a little more accurate. But before we do that, we want to make sure we know our perfect squares. And remember, there's a perfect square challenge to get you some extra credit. First perfect square is 1, right? And then 4, 9, 16. If you're wondering, this is 1 squared, right? 2 squared, 3 squared. You could figure them out if you wanted to. 4 squared if you didn't know them. 5 squared, 25. The 6th one would be 36. The 7th one, 49. Where am I at? 8th one, 64. 9th one, 10th one, 11th one. Oops, that's a silly mistake. Let me rewrite that so it looks a little pretty. 11th one, 12th one, 13th one, 14th one, 15th one, 16th one, 17th one, 18th one, 19th one, and the 20th perfect square. Okay. Now, what I need to remember is that when I take the square root of any of these, that's going to equal 1, right? Square of that one is 2, and it's actually plus or minus 1, plus or minus 2, right? But I'm going to use this idea to help me estimate a square root. So let's say I'm asked to estimate the square root of, well, I don't know, 40. Okay. Well, I look up here and I see which two perfect squares 40 falls between. Well, it falls between 36 and 49. So what I'm going to do is I'm going to list out 36, 37, square root of 38, square root of 39. Most of these are irrational, by the way. Square root of 40, square root of 41, square root of 42, square root of 43, square root of 44, square root of 45, square root of 46, square root of 47, square root of 48, and the square root of 49. Okay, so now I know the square root of 36 is going to be plus or minus 6, right? And the square root of 49 is going to be plus or minus 7, because there's 2 square roots. So now I'm going to think about a number line, and I'm going to go all the way from 6 to the 7. And I'm going to go ahead and I'm going to find the middle of this number line, or otherwise the median. And I know that from 36 to 49, there are 14 numbers. If you don't believe me, count them. There are 14 numbers. So I know some of you think there are 13. That's because you're making a small mistake in your logic. Come see me and I'll tell you what that mistake is, and I'll help set you straight. Okay, so I'm going to count 1, 2, 3, 4, 5, 6, 7. So the middle number is going to be in between there. All right. Now, if the square root of 36 is plus or minus 6, the square root of 49 is plus or minus 7, the square root of the middle would be plus or minus 6.5, right? 6 5/10, because it's smack in the middle. All right. Now I'm asked to find the square root of 40. That's on the left-hand side. It's over in here in this first half. Well, I'm going to break this half up into another two quartiles. So I think there's going to be 7 terms here. That means the fourth one is the middle. Now, if this here is plus or minus 6, and this is plus or minus 6.5, what's in the middle? Well, that would be plus or minus 6.25. Now, just to show you what I'm doing here, I'm suggesting that the square root of 39 is approximately equal to 6 1/4 or negative 6 1/4. Let's check it here. Hold on a second. I don't want that up. All right, let me get to Google here so I can show you a calculator. All right, square root of 39. Remember, I'm suggesting that it's about 6 1/4. Let's see. Look at that, 6.2449. If I subtract off my answer of 6 1/4, look at how accurate I am. I did the square root in my head, and I'm to within 5/1000ths of a number. Okay, and you can do it too. It's not that I'm got this calculator going on in my brain. It's not that at all. I'm just know how to do it. And I set it up. All right, now this that being said, we're having a little smartboard trouble here. Hold on one second. Okay, that should be good. All right, so if I have to estimate the square root of 40, I'm going to guess it's going to be around 6 3/10, somewhere right around there. Okay, so that's going to be 6 3/10. Let's go back to the calculator and see what it says. Let's do square root of 40. And look at that. I got 6.324555. That's a pretty darn good estimation. If I subtract off mine, 6.3, look at that. I'm off by 25 1/1000ths or 200ths. And I'm off by just a little over 2 pennies. Think about that. That's a pretty powerful tool. That kind of thing has the power to make you feel pretty darn smart about yourself because you can figure something out that the average person doesn't know. And the reality is it's pretty simple. Okay, let's try another one just so we have an idea what's going on. And so let's say I want to estimate, I don't know, the square root of 23. Well, I have to think to myself, what two perfect squares is that between? Well, 16 would be the lower bound, and then 17, 18, 19, 20, 21, 22, 23, 24, and the square root of 25. All right, so this is going to be plus or minus 4, and this one's going to be plus or minus 5, right? Let me get my number line out here. I always have a number line handy. Now, let me see. How many pieces of data do I have? Well, 16 to 25 would be 9, so there must be 10 pieces of data. So 1, 2, 3, 4, 5. So this would be the middle. And so that must be 4.5 plus or minus 4.5. I'll bet you if you do the square root of 21, you get a number just slightly larger than the 4.5. And I'll bet if you do the square root of 20, you'll get a number slightly smaller than 4.5. Let's test that. Square root of, hold on, what were my two numbers? 21, I'm saying, is going to be just a little bit over 4.5. Look at that, 4 58/100ths if I round. Okay, if I do 20, I'm going to get another just below 4.5. And look at that, 4 47/100ths. Too easy. You guys can do this. All right. So now I need to find the square root of 23. 1, 2, 3, 4, 5. There's 5 pieces of data. This is going to be the middle. That's going to be plus or minus 4 3/4, right? Watch how close this is going to come out. This is so cool. I'm so excited. I hope you are too, because this is really easy stuff. Look at that. 4 and 79 hundredths, maybe 4.8 if you want to round, but 4.75 is a pretty darn good estimation if you think about it. If you round up to 8 on this one, you're off by a nickel. That's pretty darn close. Okay, pretty powerful tool. All right, I think that's it for the lesson. I'll tell you what, I'm going to do one problem just so that we know how we're going to use this, what will be expected of you tomorrow. So let's say I have 3x squared minus 7, and that is going to equal, let's see here, 23. Okay, so I'm going to listen to Saddam, and I'm going to undo the subtraction first, and I'm going to get 3x squared equals 30, and then I'm going to undo the multiplication, right? And then I'm going to get 10, and then I'm going to take the square root of both sides. That's how I'm going to do this exponent in this case. So I know that x is going to be equal to plus or minus the square root of 10. Okay, well, if I want to get a rational estimation of it, well, I'm going to go square root of 9, square root of 10, square root of 11, square root of 12, 13, 14, 15, and 16. Ha, 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 ha. Okay, so the square root of 9 is plus or minus 3. Square root of 16 is plus or minus 4. And get my little number line out here. And let's see. I've got 8 pieces of data. So the middle is here. That'll be plus or minus 3.5. And then I need the middle here, which is going to be plus or minus 3.25. So my answer is going to have to be a little bit lower than 3.25. If you want to get fancy schmancy, you can even try to do like maybe plus or minus 3, like that. You could do that, or maybe you'll think it's like 2-1 or something like that. I'm going to go ahead and say it's going to be pretty close. Kind of, I think it's going to be in the 2s. I don't know off the top of my head, but I'm going to put that. Let's see how it looks, because my accuracy is the nearest tenth. What am I doing? The square root of 10, right? And it's 316. Not a bad estimation. If you're around 316 up, 3.16, you get 3.2. Okay. Now remember, I just kind of off the cheek said, you know, maybe you want to do this, and that would have been even closer. But the accuracy we demand is only to the nearest tenth. Okay. All right. That's what you're going to be doing. Mr. Lawrence signing off. Have a good night, everybody.